In this example, we want to solve another example on projectile, and the problem says a stone projected from a catapult with speed of 50 meters per second attains a height of 100 meters. Calculate A, the time of flight, B, angle of projection, and C, the range. Calculate the time of flight, angle of projection, and the range. So we need the exact formula for us to be able to solve these problems. For that reason, I am going to drop the formula here so that I would be fast in solving. Okay, so the first one says time of flight. We are going to pick the first expression here for the time of flight. The time of flight is the time for the projectile to go up and then return to the same level in which it was projected. So for us to get the time of flight, I've picked that expression because we have to consider what is given in the equation. So we have speed. This is initial velocity. So I will call this U, and height. So we have to pick a suitable expression that will help us to simplify and get what we want. We are going to take G to be 10. Okay, so applying equation 1 here, solution. Would give us the time for the projectile to go up. And for us to get the time of flight, it means we have to multiply whatever we would get here by 2 to get the time for it to go up and the time for the projectile to come down. So at this point, let me just put times here. Then the height. What was the height? 100 meters. So I'm going to erase this one and put 100. Then G. Let's take G to be 10. 2 times 100. 200. 200 divided by 10. We will get 20. Square root of 20. Square root of 20 would give us 2 root 5. Or I would take 4.42. Okay, sorry, 4.472. Equals to 4.472 in decimal. Or I can leave the answer in short form, which will give us 2 root 5. But let me continue with the decimal. This is seconds. So the time of flight would be the time for the projectile to go up and come down. So this would be 2 times the value we get for t here. So this would be 2 times 4.472, which will give us 8.8 8.944 seconds. 8.944 seconds. So I'm done with the first problem A, the time of flight. So B says angle of projection. For us to get the angle of projection, we are going to look at an expression that will come with the quantities we have here, which is U, H, and then T that we have been able to solve here. So those three quantities will help us get the unknown, which is theta. Of course, looking at this equation 2, I'm seeing U here. I will use G to be 10. So we have been able to solve for T. In place of capital T, we are going to put the value that we have gotten. And so let me make use of this equation. I'll just lift this down. Angle of projection B. Okay, so this expression is expression for the time of flight, but it will help us to solve for theta by making theta the subject. If I come here and take this to be 10, and then U, what am I going to put in place of initial velocity U? 50. This is 50 meters per second. We've gotten time of flight to be 8.944. So here we put 8.944. And then we are going to make theta the subject. Let me start from here. 2 times 50 is 100. So this other expression reduces to 100. Here, I will only put over 1 here, then I cross multiply. When I cross multiply, this 10 times this value will give me 89.44. 89.44. Let me lift this out. It will give us a linear expression. Alright, so dividing through by 100, dividing through by 100 would be 89.44 divided by 100. Alright. Alright. Then 89.44 divided by 100 will give us, remove this one to 0.8944. 0.8944. That is to say that sine theta is equal to 0.8944. Since we are looking for theta, we are going to find the inverse sine of 0.8944. So theta is equal to inverse sine 0.8944. When you use your log table or your calculator to evaluate this, you will get the value for theta, which is 63.43 degrees. 63.43 degrees. The next one is the range. The formula for range, C. Formula for range, whichever expression here would still give me the correct answer. The U here represents the value for initial velocity. This here, theta, and this one is time of flight. If you apply this, it gives you the same answer. If I still use U in place of U, I put the value of U sine 2 the angle theta all over G, which is 10, will still give me the same answer. But since this one is shorter, let me take this. You can also try by yourself. You see that what I'm saying is true. Okay, so option C. This is the formula. What's this one? U, theta, and time of flight. My theta is 63 here, 63.43. My U, initial velocity, what was it? 50. Let me start with that one. 50. Then 63.43. Time of flight, 8.944. 8.944. Okay. When we simplify what we have here, we get 200.02 meters. 200.02 meters. Okay, so please try to use the other expression. Confirm what you will get. At least we have come to the end of our class for today. And I would like you to support us by clicking on the subscribe button. Also, do not fail to like and then to share to your friends. Thank you very much. We'll meet in the next class.